Great. Thanks a lot. Hey, everyone. Thanks for joining today. Hope Nodes AI has been a good event for folks so far that are watching live. And if you're catching the recording, welcome to you as well. You can find my slides either by scanning that QR code or the URL down in the bottom left, graphstuff.com/nodesai 2026. I'll put that in the chat too, and we'll share that again at the end too. But it might be some useful resources to check out some of the slides. I want to pick up kind of right where we left off in the session earlier this morning in the panel discussion in the keynote. I want to pick up some of the topics there that we touched on and maybe drill in a little bit specifically around context graphs, agent memory, ontologies, these sorts of things. So I'm going to jump right in. And the first thing I want to talk about, and this came up in the panel discussion, is this relationship between context graphs and agent memory. And so I said earlier today that there's this close relationship. I don't think it's quite one-to-one, but I think there's a very close relationship between context graphs, and we'll go through a refresher on context graphs in a second, but there's been a lot of discussion around context graphs today. But context graphs and agent memory. With memory, we're typically thinking about some text representation, some expression of a preference or something that happened. But this is typically like file or vector, like text-based is how oftentimes we're initially implementing some of these things. But with something like a context graph or graph-based memory, we're actually extracting out the entities. So what are the things mentioned in the conversation and identifying the relationships between them? I think that's one of the most important first things that we need to think about when we're working with graphs with agent memories. How do we identify the entities? How do we go from unstructured data to identifying like what are the things, right? Like the entities are the things that exist, events, these are things that have happened. And then context, in the context graph terminology, the decision traces, this is the why, right? These are the policies that were applied, the risk factors, the reasoning that was applied either by a human employee or by an agent applying some policy, but we need some insight into the decision that was applied. And I read a blog post a few months ago and showed this demo application. It's probably still up and running, but basically a context graph for a financial services organization. We can do things like ask for credit approval decisions or responding to customer support questions as they come in. And really the architecture for this is we give the agent tools. So we give them some functionality, some way to interact with and understand their environment by querying, updating the context graph, and finding the most relevant decisions, applying those policies, generating a recommendation is a core part of what that agent is doing. Graph data science is an important component of this. We can use the structure of the graph through node embeddings. We can use things like community detection to help us find and surface the most recent or the most relevant context and decision for any step that we are in sort of our agent interaction. And this is largely based on the Neo4j agent memory Python package, which exposes short-term, long-term, and reasoning memory. So there's an important observation that context graphs need 3 types of memory. When we're talking about agent memory, oftentimes we're thinking about preferences, or we're thinking about conversations, but reasoning, the decision traces, these are also an important part of agent memory. Sometimes this is called procedural memory or experiential memory, things like that. But these are all abstractions that are baked into the Neo4j agent memory package, which we can install through pip, and integrates with pretty much any Python-based agent framework, and has lots of configurable functionality for things like entity extraction and working with graph data science. Now, I mentioned these three types of agent memory: short-term, long-term, and reasoning memory. Short-term memory we can think of as conversations, right? Conversation history, session state. This is really, though, an entry point into entity extraction, right? So we're talking about conversational, so unstructured data, conversations with an agent, and in that text unstructured data, we're going to be mentioning things, right? We're going to be mentioning customers or products, accounts. We need to go through this entity extraction and entity resolution phase to understand what is the actual thing that we're talking about. And applying just an LLM only approach to entity extraction and entity resolution can be quite slow and quite expensive. And so as part of the Neo4j agent memory package, we've built this multi-stage sort of entity extraction pipeline that is able to use named entity resolution, like statistical NLP methods, as well as smaller local models like the Gliner fine-tuned models for entity extraction that can run on CPU, to run locally for free, essentially, with fallback to LLM for more complex extraction and resolution. Now, the data model that we apply during entity extraction and resolution is really important. And that data model, I think, is going to depend on the domain that we're working with, right? Now, by default, Neo4j agent memory uses the POL plus O entity model. This is a common model that's used in investigations, right? So person, organization, location, event, object. This I think of as kind of the starting point, but as you're going through and implementing your own agent memory, I would really encourage you to extend the base data model, the base ontology that's used, and we'll see how to do that in a moment here. Reasoning memory, this is the third type of memory that we mentioned that's supported by the Neo4j agent memory package. And this is really all about understanding that why, right? The missing piece, the explanation of what execution plan did the agent make? Why was the decision made? What are the decision traces? What can we observe from the agent's reasoning phase? Those sorts of things are captured in reasoning memory, and altogether, these are the main abstractions for working with memory in the Neo4j agent memory package. Altogether, short-term memory, long-term memory, reasoning memory, these together make up your context graph, and they're all related, right? So messages, these can trigger a reasoning trace. They can trigger like the reasoning phase for the agent. We extract specific entities from specific messages. Messages trigger a tool call, these sorts of things. We've been working a lot with the different framework and agent cloud orchestration vendors. And so we've spent a lot of work making sure that Neo4j agent memory integrates well with Google ADK, with AWS, Microsoft Agent Framework. And so you'll see some specific examples and specific integrations with some of those tools as well. But there's still a bit of a challenge that I saw after we released this, and it was great to see folks adopting, especially some of the more sophisticated agent memory integrations that are out there. But I think there's still a bit of an overhead in surfacing some of this data. Like, how do I actually surface the decisions that have been made in the organization? How do I actually get that data into the graph? How do I expose that as a tool for my agent to make sense of? And so to help smooth that process a bit, we created the Create Context Graph project. Create Context Graph, this is inspired by the Create React App project, which was for a while kind of the default way of creating a React application. Go through this interactive scaffold and choose sort of what domain are you working with? Do you want to import real data? Do you want sample data just to get started? That's kind of the basic idea. And let's take a look at what this looks like. So if I run UVX Create Context Graph, it'll take me through this interactive workflow. Let's say I'm going to create a science graph project so we can suck in SAS data or generate demo data. Let's do demo data for scientific research. And we can choose which agent framework we want. Let's go with Claude Code. And I'm going to use an existing Neo4j instance. We can also connect to Neo4j Aura instance or use Docker. But I have an instance running locally on, let's see, localhost. There we go. And we're going to skip the kind of optional enhancements and add-ons here. And here I'm being asked to add an Anthropic API key. And these are optional for my agent. I can use whatever model I want. By default, we'll use Anthropic Sonnet model and OpenAI embeddings. So we've now provisioned out kind of this full stack context graph application. I'm just installing some dependencies. This is the step here to download the Spacey model. This is probably the longest step of what we're gonna see here. But if we go to the docs here, this is the Create Context Graph page, which has documentation. There's good tutorials here. We're basically following through this, your first context graph app. But okay, now we're installing the front-end dependencies. And so the front end is a Next.js application. And so we saw earlier, we had our choice of back-end framework, right? And so we chose, I think, the Claude Agent SDK. We could have chosen any of the Python models supported by Neo4j agent memory. Okay, cool. And so then the next step is to seed our database. So we'll run the make seed, and this is going to just load some sample data in my database. And then finally, we can run make start, and this is going to run the backend and the front end application. So now if we go to localhost 3000 and zoom in a bit, we should see this is our full stack scientific research context graph. So the first thing we see is the data model, but we can ask some questions here, something like show me the citation network around deep learning in drug discovery. And we can see what our agent has access to a number of tools, and it's going to choose which tools to execute to try to answer this question, right? And initially it's found a paper here. We can explore the paper and the citation network around that to bring in more data. And that's essentially what our agent is doing here, sort of doing text decipher to bring in more data to answer our question. Now, what data did we actually bring in? Like this is sample data. We see like documents. I have kind of decision traces here. I have like science papers. I have like researchers that are affiliated, and you can see like this data matches the domain that I chose, and was all generated by piping work documentation, right? So in this case, we're working with science papers, meeting notes from organizations that are allocating grants, these sorts of things. We're taking documents that represent that sort of work product and running that through the Neo4j agent memory entity extraction pipeline to construct this context graph. So that is one way to get started with context graphs and the Neo4j agent memory package. That's using sample data, right? And that's helpful for demos. But how do we surface like these real world decisions that occurred? And for that, we can use the SAS connector data in the Create Context Graph project. Currently, there's support for GitHub Linear, Google Workspace, Claude Code. There may be a few others that we've added in there. But the basic idea is we can include a connector, or you saw when we were going through the interactive flow, we were being asked if we wanted demo data or to connect to SAS, to a SAS service to pull in real data. And so for Claude Code, for example, the connector works by parsing the JSON-L session files that we have locally on our machine. And we'll parse those into a context graph and look at like what is the like graph structure of our sessions that we've had with Claude Code, right? So Claude Code is a coding agent. I interact with it by, sort of sending messages that can either be, feedback on a plan or maybe a PRD, but it's somehow related to some project that I'm working on. I'm going to be calling tools to update a file, right? Like these sorts of interactions. Now, an important component, though, of context graphs is surfacing the decision trace, right? Like, what were the decisions that were made either by a human or by an agent, and materializing those, surfacing those from our work product. And here's an example in the Claude Code connector for Create Context Graph. We do this using some heuristics. And so essentially, we're looking for the case where there was some user correction, or maybe user chose to change dependency, or there was some error. How did we resolve the error? We were presented with an alternative that was like a clear decision that the human had to make based on maybe an architecture decision, these sorts of things. What's really important is when we're able to combine these data sources and query across them. So here we're adding the Google Workspace and the linear connector. And so we can combine projects that we found in Claude Code with linear work items and maybe PRDs that we found in Google Workspace, for example. So here's just another look at some of the heuristics we use for the decision extraction, and some examples, right, where I'm using explicit statements, right? Always use single quotes, for example, right? Those are easy to sort of have regexes that are trying to identify those sorts of explicit statements. Behavioral patterns are more interesting and tricky to identify. Cool. So this is my second demo that I wanted to show. But maybe I'll skip sort of this process since we're we have limited time here. We'll skip the import process, but I'll show you a bit of what this looks like. So I pointed this at my Aura instance. Zoom in a little bit here. And we can see here, if we start by querying for projects. So I have 16 projects. This is grouse flocks. Oh, this was an experiment on adding some new visualization styling using the NVL NVL visualization package. And so anyway, we can see the messages that were sent, the tool calls that were made. Here's a tool name edit, which is essentially editing a file. We see the file that was updated and so on. And we have the same full stack like front end piece that we can use to interact with that as well as part of Create Context Graph. Cool. So the third piece that I want to talk about here is this idea of multi-agent memory. So I think it's somewhat intuitive when we're interacting with a single, maybe a coding agent using the Claude Code example. These are the preferences that I personally care about, and we can extract that and maybe a markdown file for saving that locally is fine. But the case where we have hundreds or thousands of agents that are collaboratively working together, how can we enable memory and specifically the context graph that we're using with Neo4j agent memory? How can that be a shared coordination layer for our swarm of agents, essentially, right? Like databases were created to solve this coordination problem. There are a lot of advantages that we can have there as we're leveraging that graph database as our context graph memory layer. Let's look at another example. So here we have kind of an agent swarm, again, in the financial services domain. We have, in this case, a series of agents that are all implemented in the same agent framework. So they're all implemented in AWS Strands. They share a memory layer, but they all have a somewhat different persona, right? So we have a know your customer agent, an anti-money laundering agent, a compliance agent. They all have somewhat different personas, somewhat different outcomes, somewhat different goals, but they have that shared memory layer still. Because they're all using Neo4j agent memory, they all have the same conventions, the same data models that they're using, the same contract essentially with the database for the shape of their memory. And so a typical workflow might be something like this, where the know your customer agent is ingesting new customer data, going through this entity extraction. Maybe it has some process for flagging suspicious transactions. And this can happen just in the memory layer. So in the memory layer, the KYC agent, maybe flags that, oh, this is a suspicious relationship. That's immediately available for, say, the credit agent to pick up on, because that is in the shared memory layer. Now, this example, I think this makes sense to us, and we said, okay, these are all written using the same agent framework, the same Neo4j agent memory integration for strands, is kind of how these are implemented. But what if we had a system where we had many different agents implemented in many different languages, or different frameworks? We have different different teams throughout our organization that are all working on different pieces of technology. Having a shared memory layer that all of our agents conform to the same conventions means that our memory layer can then be the layer of coordination for our agents. But we need some way to certify that those agents are all using the same conventions, that the memory layer that they're using is compatible. And this is where technology compliance kit testing comes in. And so this, I think, is something we're going to be working on in our agent memory tooling quite a bit going forward, is being able to certify that different agent memory implementations adhere to the same conventions. They have the same shape and behavior of agent memory in the graph. And when we do that, we're able to share this agent memory layer as a coordination layer. And so we've begun some initial work. There's a link here to the agent memory TCK repo, which has the specification and some of the conventions that we're using in the Neo4j agent memory tooling. This is by no means done and comprehensive, just sort of a first stab, I think, at what this looks like. And there's an example application in there of, I think we have 6 agents written in different languages, from Python, TypeScript, Go, C#, multiple versions, multiple Python frameworks. And then also just earlier today, I got the R version working. So if anyone is interested in Rlang and agent memory for R, we can now have sort of a agent memory client in that. So anyway, that I think is just kind of the vision that I want to set out for going forward in the future. Is, imagine we have all of these agents in different languages, different frameworks, all working together, contributing to learning from the same shared memory layer. Cool. Well, I think we're about out of time, but I want to leave some resources up, and then we'll go through some questions if we have time for them. Here's some links to some of the things I talked about. Graph Academy is always a good place to start. There's a new Graph Academy context graph course. Take a look at that. The Create Context Graph project, that is the command line tool used to scaffold up your context graph application, which is built on top of the Neo4j agent memory package. So those are some resources I would encourage folks to check out. I want to leave you with, I think, what was my favorite paper from last year. This came out at just the end of last year. And this was kind of a survey of memory in the age of AI agents. And I think it does a really good job of presenting a few different ways to slice up the memory landscape based on sort of like the form, function, or dynamics of the memory system. And so I'd encourage folks to check this out. I talked about some of the aspects, but just maybe not through the same lens. So I would encourage you to check this paper out as a good way to sort of have a different lens on the memory landscape piece. And I see a few folks asking for the slides. Yes, the slides. I usually have a link at the end. I forgot that. But if we zoom all the way to the beginning, we have, yes, the slides here. So the link is graphstuff.com/nodesai 2026. I can write that in graphstuff.com, nodesai. There we go. I think I typed that right. We'll see. Cool. So we have just a few minutes left. Not sure if we have time to take questions here. Let's see. I'll just scroll through the chat. Maybe we can take one or two. Let's see. So I see a few folks asking about the difference between the industry domains in Create Context Graph and like the connector data. So yeah, maybe that's good. A good shout there. So the idea with Create Context Graph is just really to be able to get started with this full text graph application. And so really the idea is choosing a domain and an agent framework. And then if you want to work with sample data, or if you want to actually connect your own SaaS service like Linear, GitHub, and if you do that, we'll actually try to identify some of the decisions that were made in your work documents through that process that I talked about. Cool. And so I see we have 1 minute left. So maybe we will pause there because I think we're going to head into the next session soon.